Welcome to today's webinar. The topic today is RWIND 2, wind simulation in digital wind tunnel. My name is Andreas Hörold. I'm responsible for marketing and PR in the company Dlubal Software. I've been working for the company for 13 years. And I'm responsible, for example, for the website, the German and English webinars, newsletters, customer projects, and so on. I will be the moderator today, and my two colleagues can introduce themselves. I will answer your questions together with Andreas. Please introduce yourself, Stefan.
Okay, so my name is Stefan Hoffmann. I'm working at Dlubal for already 4 years now, and I'm responsible for the customer support, and I'm also joining the product development for the main program RWIND and RWIND 2, and also form finding and cutting patterns. And since I'm responsible also for the development of these programs, I'm supposed to hold the webinar today, and I'm going to do so.
Andreas?
Okay, I'm Andreas Niemeyer. I'm taking care here. Hello, I'm Andreas Niemeyer. I'm taking care for development here by Dlubal. I get all wishes and transform it to the program with our development team. And today I will answer your questions.
Okay. There were some interruptions, but we could hear you. Okay, then we can switch off our webcams that the attendees can see the full screen. For the attendees who participate the first time, I would like to give some words how you can ask questions. You can show the control panel with that arrow, orange button with the white arrow. So, and then you can enter a question here and we will answer you. The other way is to watch the entire webinar and then email questions to info@dlubal.com. And then you will also get an answer. Okay, that's all from my side. I hand over the screen to Stefan. Stefan, it's your turn.
Yes, let me choose the correct screen. Okay, perfect. So I have the content slide. So once again, physics were working, so the light was faster than the speech at Mr. Niemeyer, but well, I think he faced some problems, so don't worry about it. I will now take over, and this is the first slide I want to present you today. So my content, the main part is of course about our program RWIND, but in the first part, I will also step into a functionality what we offer at our website, so the Geo-Zone tool, our load maps, and we are about to introduce a new option which you may need if you work with RWIND standalone. So we are going to implement wind profiles and also turbulence intensity there, that you can choose these values and copy paste them into RWIND, because usually our big database is introduced in RFEM6, what we of course also supposed to use RFEM6 in close coordination with RWIND 2. But this way will offer you also the option to create or gather the loads at our website and then use RWIND without RFEM6. The next part will be then the introduction into new features. So whatever you missed in the update reports from version 2.03 and 2.04, I'm going to present short some parts of these update reports, what I feel is quite interesting for you in order to be used in your wind calculation. Then the next part will be the comparison of results with experimental data. This is a new feature what was introduced. I will explain how it is supposed to work, and I will create a house with a monopitch roof where we will then compare our wind load results with the results the Eurocode offers us. And last but not least, there will of course be a prospect, so what is planned in the future. So let's step into the presentation before we start with the big modeling. So it's about the wind profile in our geozone load map. You can see a small picture on the right bottom, and we are going to introduce the output of values in diagrams and tables for these three parts. So the wind speed, turbulence intensity, and the wind pressure according to the standard. So let's jump onto our website. You can just enter dlubal.com at our website, switch into English if it is preset to German, and then you will find at Solutions on the right side our snow load, wind speed, and seismic load map. If the information is not loading for you, but I think it is already fixed, and if you're using Chrome as a browser, it may be that you have to adjust the cookies. So there's an option in Chrome that you can delete the cookies. So this is of course some data which is saved on the computer to quickly access a page, but it might be necessary to reload it. And then you can select if you want to allow all cookies again. And then the frame should load again for you if it did not do before. So let me quickly sign in that I will have enough requests for on today. And let's go again to the snow load map. So I think you're already coming to it. So it is not available yet for every map. So I do not think that it is available for Great Britain. Oh, it is already. In my tests, it was not available. Okay, so we can use, for example, Great Britain with the Eurocode 114. And then you see the small button on the left bottom of the page, which is of course still announced as being a beta. So please double check the values if they are correct or not. You can of course do that in RFEM, or at least be suspicious if they might be correct. It's still in a beta mode, but we do not want to not present it. So you can think about using them. So if you once click on the button, you can already see the three diagrams you can now gain. So it's not only about the basic wind speed. No, you directly jump into the map and parameters according to the Eurocode, and it will create you the diagram over a certain structure height. So if you would adjust in over 20 meter in here, you would see that the diagram will of course be adjusted. And you can of course as well jump into the wind profile tab in order to copy paste the values with the level. What is then of course necessary if you jump into the RWIND main program by the definition of the wind profile and turbulence intensity profile. You can as well also choose that you want to have a user-defined definition and adjust all the values you see in over here. You also get a closer look on the place where you are. You can also switch off the map if you rather want only a big display of the diagrams. So just once to remind you again, it's still in a beta phase, so it might not be available for every standard we provide, but this might be quite useful for you if you use RWIND without RFEM 6, or if you want to compare your hand calculations, or if you want to compare our calculations and tell us something might be wrong or not. So this was something not directly linked to RWIND. So let's now jump into the main part, of course, our program RWIND. And this is my summary of the 4 features I would like to mention. Maybe you are not yet used to it, but you can also find all the data in our extranet. So if you log in with your account and you go into the development tab on this page, you can see features and also bugs. And this is most likely the place where you can inform yourself of what is new or what was fixed. And if you then restrict it to RWIND, this is in German, depends on the language which is set in your account. You can see that these features were introduced into the 4th version or the 3rd version and so on. And you could also check into the bugs which were fixed for the certain files. So what I would like to talk about now is the first feature, the generation of zones from RFEM surface numbers. The next one will be the support for verification or experimental data. This will be the main part of today's webinar. The next one is a new scaling function for the wind tunnel optimization. And last but not least, we will quickly step into the display of maximum and minimum values in each time step. I have, of course, one slide for each feature, and then we jump into a small file in order to check where you can find it. So you are now able to generate zones directly from RFEM surface numbers. Of course, only if you use RFEM 6 and then hand over the model to RWIND. We will now also hand over the surface numbering, and then you are able in the edit part of RWIND to generate zones from surface numbers. So each surface, you can of course split as much as you want in the RFEM main model, will create a zone. And remaining objects, so you may of course also hand over members, they will also have triangles. They will be assigned to zone 1. So of course that's a bit a type of complication that they are assigned to zone 1. But if we now step into my example file, what is also installed, it's the concrete building where I switched on the surface numbers. You can see that we have a surface number 1. And if you do not want that 1 also includes the member triangles, you just have to once go into the table and insert a row. So the surfaces will not start with 1, and all other things should be synchronized in the back. And now we have only surface numbers starting by 2, and all other stuff may be handed over to zone 1. If this is not fine enough for your difference, we will also see it in the main example later on. You might also right-click and divide surfaces with intersecting lines in order to create multiple or more zones. So let's quickly create an example wind simulation load case. We will not care about any settings, what are able or what are necessary to be taken. We will just open our model in RWIND, which can be quickly done by the button what I used. So our geometry is handed over, and now there would be only one default zone. So it is possible for you now to hit Edit, Zones, and generate zones from surface numbers. So you quickly see that there are now a lot of zones created, and you do not have to do that manually. So you don't have to create a new zone, use the selection tools to gather all the triangles which might be necessary for your file. No, if you already consider the surface numbers or a certain division in RFEM 6, you can already directly create these zones in order to quickly evaluate maybe normalized pressure over a certain zone. I will later on show you how we will use it on our monopitch roof. And as told, you can see that there's of course also the default zone number 1, where you will then be able to find every other stuff which is not related to a surface number. Okay, so this was the first feature I wanted to talk about. We will use it later on in the next example. So let's close everything, go back to my presentation. So the next one is the support for verification and experimental data. So we now offer you the possibility to enter verification data into the table. This is yet linked to point probes and pressure values, what you can enter. And you can then display the data in graphs using labels, so the normal point probe labels. But you can also do a graphical representation of the differences between the verification data and the simulation results. You can switch that in the result navigator. You can also choose about the extrapolation of the data on the surfaces in RWIND using 2 methods, which are yet introduced. They are explained in the manual. And you can also restrict the verification data to be extrapolated to a certain zone. And we will later on use that, of course, in my main model. But in order to introduce the verification data first, I use the Volkswagen Golf, which is an example installed already if you install RWIND. And then I have already defined a point probe. I activated the option for the point probe. It might be, of course, a bunch of probes you want to enter. If you want to define certain values for zones. We now only did 1 point probe. And if you activate the verification data, you will get one more table and over here where I have entered random values. So they do not come from any tests. I just wanted to show you the labels that you can quickly estimate where are they and what are they doing. So then you will also be able to adjust the verification data options. So you can choose about the interpolation method, which is yet fixed to all point probes. So you cannot yet differ between Gaussian interpolation or diffusion, but you may set a different data range constraint for certain zones. We will see that later on in the other example. So if you also do not know about Gaussian interpolation or diffusion, you can just hit F1 on the keyboard. And usually it should be linked, but maybe we did not yet do this. So you can quickly, of course, search for verification, wait some seconds, do not wonder if you do not need to hit enter, and then choose the topic, which may be about verification data. So there is some general part of it. And if you go into the probes, I think, we quickly search it, then you can see the explanation about both interpolation methods. So just scroll down and then you will find the information about the second interpolation method, or I think also about the other ones. Yeah, so we will not phase into the theory behind it now. You can double check it if you are interested later on. What I did remember, or what I do remember by myself, is that this will most likely diffuse interpolate about a whole area in slides. And with the Gaussian, you can set a radius which will interpolate, but we will once again, of course, later on show that. And if you have these results, you can always differ between then the verification data of the scalar fields and the point probes. So you can step on over and show the results you get from the numerical wind tunnel analysis. And then you can, of course, also switch to the verification data. And I think the biggest influence will be the difference. So you can directly check according to the colors, how far is our calculation maybe away from the standard, which does not really mean that it must be far away from the reality. So there's, of course, always the question, how can we verify our model? So from my proposal, every FEA analysis or also CFD analysis needs maybe to be, of course, verified by a wind tunnel experiment. And then you can enter the data and check if your assumptions you do in this complex CFD analysis is matching with the reality. All right, so we will later on use that feature, of course, once again. So the next part is the new scaling function for the wind tunnel optimization. So you are now able to define scaling factors to automatically adjust the dimensions of the tunnel, and you will be able to save the user-defined scaling factors. So let's quickly jump into the example, which is once again the Volkswagen Golf car. And then you usually double click on the wind tunnel. So let's zoom out a bit maybe. And see these automatically adjusted values. And then there is a button of the scaling factors where you can now define your own values. Usually it is like this. So it is multiplied then with the normal values you have in the program. So this is the wind tunnel the program will offer you. But we propose most likely, if it's going into a more detailed calculation, a recommended wind tunnel size. I did already once mention this technical article by Mr. Katsemian in a different webinar, but I would like to once again put some effort into it, that it is quite necessary to think about the dimensions. So if you compare the standard dimensions to have a quick estimate of the wind load pressure and the size we would recommend which is of course then extending the calculation time a lot. If you want to compare values to the Eurocode, you can see that the size will be much bigger. And I did do, of course, a quick estimation what the values should then look like. So if you would like to match the technical article, I do not like numbers with comma, so it would be 2.7 in this length, 1.6 in this direction, and 1.85 in this direction. I would use 1, 3, 2, and 2, hit OK. Then you will be informed that these are just the factors used, and you have to use, of course, the adjust automatically button once. If you then hit OK, you can see, well, it did not change a lot because I think it was already bigger in front. But then your wind tunnel will be adjusted according to the factors you enter in here. So if you put 10 inside it, say OK, and adjust it, then you can see that this factor is going to be increased a lot. And then this will offer you the possibility to not think a lot about meter values, but to quickly enter your factors you would like to use, save them, load them, and apply them on your model. So the last feature I would like to present today is the display of the maximum and minimum values in each time step. So this means it is for the transient calculation, limited to our RWIND 2 Pro version. And it will offer you to have some kind of envelope for surface pressure or CP coefficient values. So let's jump once again to the golf car. There's also a transient calculation file for the golf car. So what it is about now is that usually if you do not show the transient flow results, you will have a slider over the time where we can see most likely on the back part of the car that the pressure will of course change over time due to the wind acting, of course, turbulent. And then it would be kind of hard to evaluate where will be the maximum suction or the maximum pressure. Or if you are lazy and you don't want to check that, you will now be offered to show the transient flow extremes. And if we, of course, use 2 monitors, we can once show the minimum in time, which might be minus 0.814. So it's of course the minimum with a minus. And we can then also choose to show the maximum in a time. So this same point probe would be in a transient calculation over time, gaining the values of minus 0.733 or minus 0.814. So this is one way to determine the maximum or minimum values for your structure or your file. You can, of course, also switch that value in the view navigator, but I think the quickest way is, of course, to do it on the right. Okay, so this was kind of a slide presentation, but was also stepping into the program. And now I would like, of course, to show you how we can use the feature of the verification data on an example. So it's a building, it's 10 meter long, 8 meter wide, 4 meter high, and it has an angle of the roof of about 5 degrees. So it's a monopitch roof. And we will apply the zones for a monopitch roof. If the wind is going into the main X direction, there will be 3 zones. So the F zone, G zone, and H zone according to the Eurocode. And it will be divided into these parts. So we will use, of course, the generate zone function in our model. And we should get these zone dimensions. So I have stolen them from the wind load assistant because this is a known example type of roof for the Eurocode. And it is supposed to have these pressures on the certain zones. So we will start with a fresh model in RFEM 6. So let's give it a name. So it's the name of today, and it's called a monopitch. And what we of course need to activate, we will not do any design to elements. So it's just really about to give our model into the wind simulation analysis and gain the pressures of it. So I will only activate wind simulation. I could activate all because I'm working for Dlubal, so I'm not limited to any add-on, thanks to that. And we will do it according to the German national annex, because we are quite used to do so, and we also tend to present our English webinar for the German annex. What you can now as well do is choose already a location in the Geo-Zone tool if you want to. We will do that later on. And you could as well also define a terrain. Just remember, it is possible, but since we would not like to have any influence by neighborhood or by the terrain, we just skip that. So once the file is loaded with all the data used before, remember that the first angle of wind simulation load is going into the global X direction. So I tend to rotate my model because I dislike to rotate the wind load. And I will now start by modeling the bottom plate. So I will simply use the rigid type, because I'm only interested into my wind load on the structure. I'm not interested in any design yet for the building. So it does not matter if it's concrete or metal. We can just use rigid because I do not account for any stiffness. So now I told that it is 10 meters times 8 meters. So we would now, of course, need to define this size in our program. So where did I choose it? So I'm starting at minus 0.5, and we're going to 5 and 8. So this will be the bottom plate. Then we can simply, with the control key on the keyboard, mark all the lines, hit a right click on them and extrude them into surfaces. This will offer you the possibility to quickly model a surface. We will once again use the rigid type, and the height should be 4 meters into minus z. Okay, we apply that. So we most likely have already our hull. You can, of course, switch into this display if you like it even more. And then I would just mark my bottom surface and copy paste it with the control keyboard and snap it to the top. We, of course, need some boundary conditions at least. So I would just apply some line loads, being some singular foundation on the length. And then it's, of course, about to define the angle. You can quickly do that by simply hitting the surface and use the manipulation tool to chamfer it. So you can now decide that you want to chamfer it, for example, 5 degrees. Due to our wind load assistant, I use a 5.01. And then we need, of course, to think about what will be the direction. So it is about our y-axis. So this is the turning point, and it should be into the z direction. So we want to have it into the global z direction. Since we use this point already, you don't need to choose it, but we can, of course, once choose a node in here. And if we hit OK, it is moved. Since I only selected the surface, all other combined elements are not moved. So we could simply before mark everything, or we now just mark both nodes and drag and drop them to this position. And then you can see that the surfaces are quickly adjusted. So it's quite smart. If you would like to model, it's close to a CAD design, I think, that you can use, of course, drag and drop and so on. So the next thing we would like to do is, of course, to check the wind load areas. We can do that with the wind load wizard. This is not our wind. This would be the standard approach. And we are now only interested in the mono pitch roof. And then you see the picture, what 4 corner nodes you need to choose. So we simply pick our 4 corner nodes and hit OK. And then we introduce the parameters. So now I hit the button to jump into the Geo-Zone tool, and I will use the location of Leipzig. It does not matter where we are. You can see that the German standard will choose the wind zone 2. I will load all the data. It will gather all information from the Geo-Zone tool, so we do not need to enter them manually. And then I can adjust the structure height, which is roughly 4.7 meters, and we will use the terrain category 2. If we do that and create all the wind load cases, we can quickly estimate the results already. So you see the load directions and you see that our zones will be split. So if we jump quickly back into this part, we will be given all the data, what the standard will give us. So the width of the zone F, so E divided by 4 is 2.35 meters, and the E divided by 10 is 94 centimeters. So you will be given this information. This is why we do it as well shortly with the load assistant. And if you display it, you can see that this is the load or the suction we are going to experience in our wind, and we will then check it. So let's continue. So what we now want to do is that we already define now zones. So we would like to split the roof into parts. For that, we would like to have our lines showing into the same direction. So now we can use both lines, hit the right mouse button and divide the line via distance. So now we could just simply enter 94 centimeters, but it is meant as a projection showing from top. So you are now able, of course, also to use now the projection of the line into the local X direction. You can enter 94 centimeter in here. And if you do that and hit OK, you can quickly divide the line using it for further modeling. We will now simply draw a line into here and have now the line which is going through, and then I told that the distance will be 2.35 meters. So we will use this line and also divide it with a distance. It's now not about the projection or anything, since it is the same if we use it, and split the line at 2.35 meters. And we will also divide the line at the distance at the end, 2.35 meters. Okay, so if we now have it, we can now, for example, simply use or mark this node and copy it from this point to this point in order to have it. Or you can, of course, also try to hit the tool in order to snap the perpendicular part. I'm not sure if I activate it. So I just simply use, for example, also this line and copy paste it on over here. If you are curious why maybe there are red nodes or blue nodes created, so if the line divides or not, you can step into the program options and choose the setting, what it is supposed to connect members or lines. If you do not manage to do so, you can simply later on, once use this function, go over and check if the lines will be divided. So the last part we would need to do in order to have certain surfaces is to right-click on the roof and divide the surface with intersecting lines. And voila, we have now 4 surfaces for the top, which will be giving our 4 zones as expected and what we would like to do so in order to compare it with our experimental data. So this is a way, this is one possible way. If you have a quicker one, of course, you can also use your way of modeling. Next part we would need to do is for the wind analysis to step into the mesh settings in order to check what wind simulation options we would like to use. So you can think about the level of detail or the simplification of the model. You can think about only visible objects that they should be handed over. Since we do not have members, we can just deactivate this option. We will also not hand over any terrain. We will also not hand over any surrounding models. Let me shortly drink something. And we will also not keep the wind simulation results. Since we use rigid surfaces, we do not need to think about surface thickness, and run RWIND in silent mode is mainly supposed if you have a lot of load cases and you do not want to double check them and to manually start the calculation in RWIND. You can disable this button, and once you calculate a wind load case, RWIND will open and you will be given the option to adjust everything you would like to do. So if you want to double check the model and then start the wind calculation by your own. The next part is that we need a new load case, of course. So it will be the action category wind. It has to be the analysis type wind simulation. And then two registers will open on the top. There you can choose for the wind simulation, of course, further settings. So the first one would be the wind profile. If we step into it, you can see that this is, of course, once related again to a certain destination. So we once check again Leipzig in order to load the data inside it. You can also manually define it if you want to. We would just change to the category 2. The height is taken automatically by the program. We will not adjust any other factor inside this. And there you can already see the profile, which should match with the ones I showed in the beta phase. But due to the beta phase, there might be still some adjustments. Using this button, you can switch between the turbulence and the wind profile, or you could also be able to see the wind velocity given in the tables. If we defined it, the last part would be to double check the wind simulation analysis settings. So if you would like to do a basic steady flow calculation or a pro transient flow calculation, this is always up to the structure and turbulence you are expecting. We will simply do a steady flow calculation. We will use the presets given on over here. And if it is up to some certain controlling of standards, we would propose to also activate the boundary layers. But for this, please check out our technical articles, because Mr. Katzemian did provide a lot of verification examples and also a lot of nice to know facts for maybe beginners in a CFD analysis, because we offer a tool with a quick estimation of results. And there are still technical parts in behind what you may be curious to know about. There are other things you could adjust, but we will just leave it like it is. So if we would now hit OK and start the calculation of LC10, you will see that it will now hand over our model to RWIND. It will start RWIND. And we would now be able to, of course, do the stuff we would like to do. So currently it would be necessary to manually generate zone from surface numbers that you can later on use it. Of course, we are planning that there should be some automatically option because usually it might be wanted from you that you would like to automatically create zones. If everything is done, we could now start the calculation, but since this will take 5 to 10 minutes, even for this file, I will not do it in this file. I will open my already calculated file. So of course, RFEM will give me some error. Okay, I did already run the file, of course, for you. So let's make a jump into time. So 10 minutes passed. We now have already our results on the model. Let me quickly just delete the line probe I already defined in here. So we have already our zones being also defined. So our zone, I always have to double check. Zone 7 is the big part H, 8 and 9 is F, and 10 is G. I hope I will remember it. If not, I will have to double check it again. So what we are given now after the calculation is, of course, the pressure for our front and our roof, sides, and so on with the certain values. And now if you would like to compare that to different standards or to your analysis, we will define a new probe. I will name it F for the zone F. So this will be these small parts in our model. And then we will define it on the simplified model, on the original model, sorry. So the original model, if you are curious on what the model meshes are about, there is a big chapter in our online manual, because this is one main part of RWIND that we give maybe a non-topological correct model into RFEM to RWIND. It will create a fine mesh for the CFD analysis and transfer back the forces onto the model. So let's start by setting point probes graphically. So we are now only interested into the roof. So the part F, I will use 2 probes in over here. You will see them soon. I hit finish, and then I will quickly switch to the RWIND results, because it was still set that we show the verification data. And then we can see that we have those 2 point probes giving the results at this point for our zone. And if we now would like to introduce verification data, we just apply this button and we will check what the standard is thinking of. So it's minus 1.19 kilonewton per square meter. So let's hit or let's enter minus 1.19. Oops. And quickly check that this will only be used now for the zone number 8. And let's use the diffusion interpolation, say okay, and let's quickly switch the data to the verification data, because I think this is a smart way to see what now the logic is doing in behind if you enter these probes. We now inserted 2 probes for the zone. We restricted it to be only interpolated in this area. So what it tries now, of course, to do is to keep the minus 1.9, and to the boundaries, to the other surfaces, it tries to interpolate. We will now introduce some more points. So I will just enter 1 more in the other area, say okay. We go in there, it already has the latest value. And if we would switch now to the Gaussian interpolation with a radius of minus 0.72, hit apply. Okay, let's put this window in here. We will see that nothing is done in here. Keep in mind, we restricted it currently to 8. We can also restrict it to 8 and 9. And then we see that the interpolation is done in a bit different way to the diffusion. So if you see diffusion, it is using a wider area, and Gaussian is using the automatic parameter defined in here. So it's a radius around the dot of 7.3 centimeters. We could also uncheck the bottom and increase the area or decrease the area. So it depends on how much probes you would like to set. So in a normal wind tunnel analysis, in reality, you have a certain amount of probes over the height. Since this would most likely extend my webinar to more hours to introduce such an amount of probes, we will only use 1 probe this time, and we will simply increase the radius, for example, to 3 meters, because this way most of the zone will be covered by my defined verification data, and all the other stuff will then be later on interpolated. So we will set a new probe for the next area. So this would be G. We will set it graphically. So we will once again only use 1 dot. It will be more usually. So I set by mistake 2. So let's only keep the first one we used. You can also later on adjust the values we used in here if you need to do so. And we will now once again define the verification data for this part. So let's jump back. Should be minus 0.84 according to the standard. So let's enter it. And as you can see, this part on top is limited for all probes, and we will define this probe only for the part number 10. And then you can see that it will also interpolate between the zones a bit better than it was doing on before. So now we have already defined 2 parts. So let's enter our last probe, which would be about the H area. Once again, I only set 1 probe on over there. We define the verification data, what is supposed to have minus 0.42, sorry. And we assign it only for the zone number 7. If we hit apply, we can see that our radius is, of course, since the zone is about 7 meters and 10 meters, it's way too low, but it does not matter. We can, of course, increase the factor in over here, for example, to 6. For our example, to extrapolate our value to the whole zone. So if we did that, we now have a smart graphical representation according to the values. Of course, the standard is offering you, I think, some summed up value amount for the zones. So you would only have yellow, blue, and light blue for the zones, which might, of course, differ to the reality values we achieve. And now we can go into the View tab and say, okay, these are our RWIND results. You can see the probes, of course, also then show the values our RWIND is giving us. This is the verification data, and now big drums. We can now also check the difference about it. Let me quickly restrict our zones only to the roof. You can do that usually in the section tab. And then we can see that the dark blue would be a difference of 0 most likely, and the wider away we are, we will have a bigger difference. But of course, the standard is not really taking into account is maybe a finer determination of an area. So we might have some bigger differences to the standard. What I did not do is that I have done a long calculation. So what I did is having the wind tunnel size recommended, but only a model simplification factor of 2. So this is not the best calculation giving the best results, but some quick results. And we can see that, well, we are, of course, away from the standard in certain areas, but you could also try to double click on a zone. So let's, for example, use zone number 7 and get the information about what are maybe the average values inside the zone in order to double check them as well and compare them to the standard. So this is most likely the biggest new feature we introduced for you in order to compare the stuff with experimental data. So what you could, of course, also do is enter more probes, define more areas, and think about what verification interpolation you are going to choose. So I was just about to jump into the point probes, but maybe my computer does not like it. Okay, so I was most likely even done with this. So let's continue with the presentation. I see I'm a bit ahead in time, but I think this is no problem. So last but not least, the prospect of today. We, of course, try to constant expand our database of verification examples. So if you do not know, you can find them in our download area. There is the verification example area where you can filter for RWIND and RWIND2. And there we provide already some validation. For example, the latest one, validation and a comparison to a Japanese wind tunnel base, where you can see that also, of course, zones were created and double checked and compared to the standard. Where is the experiment? Where is the standard? And where are we? So it's not about judging what is the correct result, I think. So because I think nobody really knows what assumptions the standard really did in the past, but it's most likely just about to get a feeling, is my CFD model matching with the reality or not? And maybe I can even get lower values, which might be a bit more economical, but still on the safe side. So you can find all the input values, and if you scroll down, there should also be then the model to download. So you can already gather these models. Maybe if you have a similar model, put them into the tunnel with the settings we did, let them run, and then gather the information you may be curious about. What I did not show this time in the webinar is the connection of the results from the RWIND to the RFEM GUI. So what we are going, of course, to introduce more is that you can run RWIND as a solver in the background. There is a tab then in here if you are in the wind analysis load case that you can switch to the RWIND results. Currently, I think it's only the pressure and the CP coefficient being drawn in over here in order to be evaluated. We also plan, that's not fixed, the expansion of the results values as Q-ISO surfaces. I never ever heard about them yet, but I'm not that scientific CFD analyst. You can find in the OpenFOAM user guide information what this vector feed is about, and if this is useful maybe for you to evaluate your model, you can check out these results hopefully in an upcoming version. And last but not least, beside all other features, what is planned, we of course planning to as well offer more wind tunnel scaling options that can be transferred then from the RFEM GUI to the RWIND GUI. All right, Andreas, so I'm a bit ahead in time, 5 minutes, but maybe you can close the gap and I would hand back over to you.
Okay, thank you, Stefan, for this nice presentation about the current state of our wind. And yeah, we're quite curious if the features are integrated in the program in the next time. Okay, before I show you our website with the recording and models that you can download, I would like to hand over the screen and show another slide in the PowerPoint presentation. I would like to give you the hint that you can book your free online appointment, such as a product demonstration. Then just contact our sales team. You can scan the QR code or click on the link. You can download the PowerPoint slides from our website. Also, if you would like to get a non-binding offer or something like that, just contact our colleagues. Okay, then let me switch to our website, dlubal.com. And under news and events, you can find the webinars. Those are, this is the today's webinar. Those are the webinars in the next time. That's the webinar of next week. How to integrate artificial intelligence to RFEM using the API. Then the week over next week in USA webinar about the new add-on time history analysis. And yeah, those are the other webinars of the next weeks and already of the next year. Let me click on the today's webinar. Yeah, you will get an email in the next days when the recording is online with a direct link to that page. Then you will find the recording in the middle here. You can already download the presentation slides as a PDF file, and you can, or you will find the models of today's webinar here at the bottom. Okay, then that's also all from my side. I thank you for your attention. Thanks to Stefan for the nice presentation. Thanks to Andreas Niemeyer for answering the questions. I hope we meet each other in another webinar. When we don't meet us in this year, I wish all nice or happy Christmas and a happy new year. And yeah, bye-bye.